Okay, we are going to talk about how to factor trinomials. In this situation, it's both a trinomial and it's a quadratic equation as well. We talked about quadratic equations kind of at the beginning of this chapter. We've also talked about how to factor binomials, and now it's trinomials. Now, the thing about it is, with binomials, we look for a GCF right away. Here, we're still going to do that, but as you can see, we have x, this has no x. We have 1, 10, and 16. There's no GCF. The only GCF we have is 1, and 1's not going to change anything. So, since we don't have a GCF to pull out, we need to make 2 parentheses. And we already know to get x squared, we take x times x. If we were to FOIL this, we would get our x squared that we want. Okay, now we have our A, B, C. Okay? We need to look at the factors of C so that we can add to get B. And this is what I mean. We need to look at factors of 16. So I know 1 times 16 equals 16. I also know 2 times 8 equals 16. And I also know 4 times 4 equals 16. So those are the factors of 16 that we have. Now we need to pick from here. We need to add them together. Which can we add together and get 10? Well, we notice if we add 1 and 16 together, that's going to be 17. So that doesn't work. 2 and 8, that'll be 10, and 4 and 4 will be 8. So we know we want to use 2 and 8. And in order to get a positive 10 and a positive 16, we need to have a positive 2 and a positive 8. Now again, all we have to do, we need to look at 2 numbers that can multiply to equal C, but add to equal B. Okay, go ahead and try. Go ahead and try that top monitoring progress 1 and 2. We'll go over example 2 together. Okay, hopefully you've tried the monitoring progress already. If you haven't, go back and pause it. But we know x times x is x squared, and we also know that 6 times 1 equals a positive 6, and 6 plus 1 equals a positive 7. So that's what we want. We look at number 2. Again, x and x. We look at the factors of 8. We have 8 and 1. We have 4 and 2. That's about it. So we can use 8 and 1 to get to a positive 9 by adding them. Now, if I were to ask you to solve these, all we would have to do is set it equal to 0, split them up, and solve. But since I'm not asking that, we don't have to worry about that right now. Okay, if you did not get those right, make sure you go back and try again. Go back and watch example 1, etc. We look at example 2. Same process. We have A, B, and C. We need to look at the factors of C that we can use to add up to be a negative 8. So, let's write our 2 parentheses. We have x and x. Let's look at the factors of 12. We have 1 times 12. We have 2 times 6. We have 3 times 4. Okay, I know that if I add these together, I'll get 13, I'll get 8, and I'll get 7. Now, the thing about it, though, is we need to get a negative 8, but a positive 12. So if I make these 2 negative, that's when that's going to work. Because we know a negative 2 times a negative 6 is a positive 12, because a negative times a negative is a positive. And negative 2 plus a negative 6 is a negative 8. That's what we want. Moving to the next one. Again, we just put our n and our n because we cannot pull out a GCF. Let's look at the factors of 35 that we could use to equal 12. We have 1 times 35. We have 5 times 7, which is the one that I would probably use. Because I know 5 plus 7 is 12, but it has to be negative. And I also know a negative times a negative is a positive, and that's what we want. So we'll just go ahead and make these both negative. Negative 5, negative 7. Pretty much the rule of thumb is if B is negative, both of these are going to be negative as long as C is positive. If B is negative and C is positive, both of these are going to be negative no matter what. Okay, we're going to do example 3. Now this is a little bit different because again we have our A, B, and C again, but now B is positive and C is negative. Now our rule is going to be 1 has to be positive and 1 has to be negative. So let's take the factors of 21. We have 1 times 21. We have 3 times 7. I don't think there's any others. So we need to figure out, we know that 1's going to be negative and 1's going to be positive. Every single time we have B positive and C negative, because we know a negative times a positive is going to get us a negative number. Okay, so let's look. We have 3 and 7, we have 1 and 21. 9 times out of 10, this one's never going to work, but sometimes it does. So we have 3 and 7. How could we use 3 and 7 to get a positive 4? Well, we just make the lower one negative. So 3 goes here, and 7 goes here. Again, we know a negative 3 times a positive 7 is our negative 21, and we know a positive 7 plus a negative 3 is 4. That's exactly what we want. And you can always check yourself when we do this factoring by foiling. All you have to do is foil like we did earlier in the chapter and see if it matches this equation. If it doesn't, you've done it wrong. If it does, you've done it right. Okay, let's do this one now. Again, we have our y and our y. We need to think of factors of 30. And anytime that c is negative, it's going to be a positive and a negative every single time. So we have 1 and 30. We have 2 and 15. We have 3 and 10. And I'm going to stop there because I already see 1 that's going to work. Now, you're going to be thinking in your mind, I know 3 plus 10 is 13, but it has to be positive in order for that to happen. So since we need a positive and a negative, I'm going to use 15 and 2. Because if I used 3 and 10, that wouldn't give us the answer we want, but 15 and 2 will, because 15 plus a negative 2 gives us our positive 13, and 15 times a negative 2 gives us that negative 30. So every single time C is negative, you're always going to have a negative and a positive every single time. Okay, go ahead and try our monitoring progress. Ooh, maybe. Yeah, go ahead and try this monitoring progress. Give it a shot. I'm just going to write the answers. Go ahead and try it yourself. Okay, hopefully by now you've tried it. This one we needed to have our W, and to get a positive 3 but a negative 4, we need to have a negative 3 and a negative 1. The only factors of 3 are 1 and 3, so I had to work somehow. We look at 2. We have x and x. Our factors of 24 that can give us a negative 14 would be a negative 2 and a negative 12. Okay, we look down here at 3. We know we have our x and our x. 15 only has 4 factors, 1 and 15, and 3 and 5. We know 3 and 5 can get us 2, but it needs to be a positive 2, so that tells me we need to have a positive 5 and a negative 3. And finally, we look at 4. Ones like this are kind of difficult because we know 42 has a few factors, and it's not every day you're thinking of the factors of 42, right? But I know that I have 1 and 42, I have 2 and 21, I have 3 and 14, I think. But the one that we're going to use is 6 and 7 because we see this negative 1 right here. So if we want to keep that 1 negative, we make our bigger 1 negative, which is 7, plus 6. Okay, so we've gone over how to factor trinomials. You guys should know by now how to solve these because we did that in 7.4. We solved ones that look just like this. All you have to do is split them up and have them equal 0. But today we're just worried about factoring.